Chapter 4, Section 1, Integers as Exponents. In this chapter, we're going to talk about integers and exponents dealing with polynomials. So we've already discussed this particular slide. We discussed this in a little bit in Chapter 1. Exponents are used to indicate repeated multiplication. And so what's going on here is if I have something that says 4 to the third power, 4 to the third power is equal to 4 times 4 times 4. So basically if you have a power such as this, your base is the big number and your exponent is the small number. And so what 4 to the third power means is it means to take your base and multiply it times itself 3 times. And so a lot of people think that this is 4 times 3, which is 12, and that's not the case. Instead, this is 4 times 4 times 4, which is 64. And so as I said, 4 is the base, 3 is the exponent. Now, the exponent tells us how many times we will multiply the base times itself, as I said earlier. I want you to be careful with this scenario down here. And again, we talked a little bit about it in Chapter 1, but we're going to talk about it again here. So notice, be very careful. If you have something like this, if you have a power that looks like this, negative 5 to the third power, you need to understand that that negative symbol has nothing to do to the third power. Instead, what this says is the opposite of 5 cubed. And so what you're going to do is you're going to think of the negative sign as the opposite sign. 5 is your base, not negative 5, but 5 is your base. And so what you're going to do is you're going to have the negative sign on the outside, and then you're going to do the 5 times 5 times 5. Whereas, if you do see the base in parentheses, such as this, then your base is negative 5. And you're going to do negative 5 times negative 5 times negative 5. So what is the difference? The difference is when you don't see parentheses, you're going to do the power and then take the opposite of your answer. Here, though, you're going to do the negative with the base. It is a part of the base, so you'll use it in your base, negative 5 times negative 5 times negative 5. It will change your answer, so be careful with that. Okay, so when the problem says what is the meaning, don't forget this because we won't come back to this until probably the study guide or the actual test. When I ask you what is the meaning of the following exponents, what I'm asking you is to expand it. And so x to the fifth power is going to be the same as x times x times x times x times x. So I'm just asking you to take the base and expand it times how many times the exponent tells you. So here, your base is 3t. And so you're going to do 3t times 3t because it's 3t as your base squared. But in the third problem, your base for the 2, the only thing that you're squaring is the t. So this one is going to be 3 times t times t. And it's important that you know the meaning of these. And so this one, again, your base is negative x, so you'll have negative x times itself 4 times. This one, however, says to take the opposite, and your only base is going to be y. So you have y cubed. So again, it's important that you understand the meaning so that you can evaluate these. Okay, so our first rule that we're going to learn is the power of 1 and the power of 0 rule. And you need to know these. You can write them on your index card for your test if you want to, but for here, anything to the first power is itself, and anything to the 0 power is 1. And so 6 to the first power is 6. Anything to the first power is itself. And anything to the 0 power, and this is tricky, but anything to the 0 power is 1. Okay, so let's evaluate. Again, we've been doing this since Chapter 1. Evaluate means basically that we're going to substitute. So we evaluate algebraic expressions by replacing the variables with the numbers and follow the rules for order of operations. And like I said, we did do this in Chapter 1. And so if we evaluate t to the third power when t is equal to 5, we're going to replace t with 5 to the third power. And we already know that that's 5 times 5 times 5, which is going to be 125. The one to the right, here you're going to replace x with negative 2. And I'll make the suggestion again, I made it in chapter 1, but when you have to plug in a negative base, a negative number, please use parentheses. And so notice the only thing I did is I replaced that x with negative 2, because the initial problem says negative 5 times negative 2 to the, negative 5 times x to the 5th power. And so when you replace x with negative 2, because that's what it's equal to, then you're going to have negative 5 times negative 2 to the 5th power. This is where your order of operations comes into play. So remember PEMDAS tells us in a problem such as this we have to do our exponents before we do our multiplication. Exponents before multiplication. And so we're going to do this negative 5 last. And so negative 2 to the 5th power, you can do that in your calculator. Negative 2 to the 5th power is going to be negative 32. And then negative 5 times negative 32 is going to be a positive 160. Okay, so these two down here is going to help us realize the parenthesis rule that we were talking about earlier. So the one on the left, your base is 4t. So that's going to be 4t squared. And so we have 4 times t, which is negative 3, and then we're going to square that. So here, you're going to do parentheses first, and then your exponent, because that's PEMDAS. So 4 times negative 3 is going to be negative 12, and then squared is going to be 144. But over to the right, your base is only the t. And so you're going to do negative 3 times negative 3, or negative 3 squared. I guess that's what we would do. And so now here you're going to do the exponent first. And so you'll have 4 times negative 3 squared is going to be 9, and 4 times 9 is going to be 36. So I need you to understand the difference here. In here you have multiplication, you have a multiplication inside the parentheses. And so this time your parentheses are grouping symbols, because there's something inside to do. Here, however, there's nothing inside to do, so they're not a group, so you're going to do your exponent first. So you've got to get that straight in your brain. When do I do the inside multiplication first, and when do I do the exponent first? It all depends on these parentheses. The next rule that we're going to talk about is multiplying exponents with like bases. And so this is called the product rule. And so when you multiply powers with like bases, you simply add the exponents. So to multiply exponents with like bases, you're going to add the exponents and keep the same base. And that's important. Keep the same base. Your base is never going to change. Whether it's a variable or a number, your base will not change. So for example, we have x to the 7th times x to the 8th. Your base is x, so it's going to stay x all the way through. And you're going to add those exponents, 7 plus 8, which is going to give you the 15. So to multiply exponents, what you're going to do is you're going to multiply your coefficients first, and then multiply like bases by adding their exponents. So in this problem, we're going to take our coefficients, 3 times 4, and get 12, and then like bases by adding the exponents. So x to the 2nd times x to the 3rd is x to the 5th. And y to the 1st, there is a 1 there, times y to the 2nd is going to be y to the 3rd. So if you don't see an exponent, you can put a 1 there. It's understood to be 1. Okay, so let's put that rule into play. For letter A, you have 3 to the 5th times 3 to the 5th. Remember, your base is not going to change, and you're just going to add those exponents. To multiply powers with like bases, keep the same base and add the exponents. So here, x to the 4th times x to the 6th is going to be x to the 10th. X to the 1st times x to the 4th is going to be x to the 5th. And then when you have multiple bases, you're just going to multiply like bases by adding the exponent. So you're still going to have a base of A, but you're going to have an exponent of 9, and you're still going to have a base of B, but you're going to have an exponent of 8. Alright, the next rule is dividing exponents with like bases. So divide powers with like bases, you're going to subtract the denominator exponent from the numerator. It's always going to be top minus bottom. So when you divide powers with like bases, you're going to subtract those exponents, and it's always going to be top minus bottom. And of course, you know anything divided by itself is 1. So here, for example, you're going to keep the base the same. So the base is 4, and then you're going to subtract those exponents, 5 minus 2, which is going to be 3, so it's going to be 4 to the third power. For letter B, you're going to keep the base the same, and 6 minus 2 is going to be 4. And for C, again, like bases. So you're going to have the base of A, but you're going to do 7 minus 3, which is going to be 4, and then you're going to do the base of B, and then 6 minus 4 is going to be 2. Okay, the next rule is the negative exponent rule. Anytime you see a negative exponent, just understand that you are looking at a fraction. Anytime you see a negative exponent, whether it's a fraction or not, you are looking at a fraction. And that negative exponent tells me to take the inverse. Take the inverse, which means flip it over. So for example, if this is a whole number, then I would put it over 1. So to get rid of the negative exponent, I would have to take the reciprocal and do 1 over a to the positive n. And that's what we're going to do. We're going to express with positive exponents, and then we're going to simplify if we can. So for example, if we have 4 to the negative 3 power, that's a whole number. I see the negative exponent, so I'm looking at a fraction. To get rid of the negative exponent, I'm going to flip the fraction and raise the power to a positive exponent of 3. And then we can simplify that. 4 to the third power is going to be 64, so you get 1 over 64. And that's why I say when you see a negative exponent, you are looking at a fraction, which in this case is going to be 1 over 64. Okay, so for letter B, notice our base is a negative 2. Now we're not trying to get rid of the negative on the base because we've dealt with negative numbers all the way from chapter 1. What we are trying to do is trying to get rid of the negative on the exponent only. And so again, this is a whole number over 1. So to get rid of the negative exponent, we're going to do 1 over negative 2 still, but it's going to be raised to the positive 3. And so you're going to have 1 over negative 2 to the third power is going to be negative 8. So you have 1 over negative 8. Okay, letter C is a little tricky as well. You have to understand that this says 4 times negative 3. And so 4 has its own exponent of a positive 1. And so the 4 is good. It doesn't have a negative exponent, so we're going to leave it alone. So remember, if you see a negative exponent, you're looking at a fraction. So because I have a negative 3 here, I am looking at a fraction. So I am going to go ahead and put this over 1. However, if this is not in parentheses, that negative 3 has nothing to do with the 4, and so therefore the 4 has its own exponent of positive 1. So the only thing that you're going to flip is that p. So the p to the positive 3 is going to go to the bottom. So do you see that? The 4, since it has a positive exponent, stays on top. But since the p has a negative exponent, it's going to be pushed to the bottom. So an easy way to remember this is this. If you have a negative exponent on top, push it to the bottom and make it positive. Look at D. If you have a negative exponent on bottom, push it to the top and make it positive. So again, anytime you see a negative exponent, that simply means to take the reciprocal, raise it to a positive exponent, and put it over the numerator. In other words, just take the reciprocal. And so of course anything over 1 is itself, so x to the second power over 1 is the same as x to the second power. So now we're going to put all of these rules together. We have our multiplying of the like base, we have our dividing of the like base, and we're dealing with negative exponents in all of these. So let's look and see how to do this. Now, the first rule that I taught you was the multiplying powers with like bases. And right now, because we just came through with the negative exponent, you're thinking, oh, well, I need to flip this. And that's fine, but to me, it's easier to go ahead and use our product rule when you multiply powers with like bases. The base stays the same and we're going to add our exponents. Well, we know that negative 2 plus 4 is a positive 2. And our negative exponent goes away and we get 25. So 5 squared is going to be 25. So here, when you multiply powers with like bases, you're going to keep the same base and add those exponents. Well, negative 3 plus negative 4 is negative 7. Well, this time our negative exponent didn't go away, but we know that we can take the reciprocal and do 1 over x to the positive 7. So for letter C, we are dividing. Remember, when you divide powers with like bases, you keep the same base, but you subtract top minus bottom. And I'm going to write this one out so you can see it. Negative 2 minus 3, top minus bottom. And so when you do that, you're going to have negative 5, 7 to the negative 5 power. We don't want our answers to be negative exponents, so we have to change that to 1 over 7 to the positive 5. Letter D, same concept. We're dividing powers with like bases, so we keep the same base and we subtract top minus bottom. And so this time we're going to have b to the, remember if you have double negatives, this goes to plus, so you have negative 2 plus 3, which is going to be 1. And then remember, anything to the first power is itself. Letter E, this numerator of t has an exponent of 1. So remember, when you divide powers with like bases, you keep the same base, which is t, and you do top minus bottom exponent. And so we have double negatives, and so we get t to the positive 6. 1 plus 5 is going to be 6. Alright, so what I would like you to do is I would like you to try these problems. And as requested, the answers are on the next slide. So, do these problems and then check your answers if you want to here. If you printed out these PowerPoints, it's just easy, to flip to the next page. If you have any questions, bring them into class. I'll be happy to answer them.